to find the longest palindrome substring, all right? So the interviewer tells you, well, given a string, find the longest substring of the string that's a palindrome. What would you ask if the interviewer asks you this? What would your first questions to the interviewer be? All right, some great questions there. Are special characters or commas to be considered or ignored? That's a very good question. So let's say the interviewer says you don't have to worry about it, but that's something that you might have to handle when you're dealing with palindromes. You guys know what a palindrome is, right? It's basically a string which reads the same both ways. Typically, people ignore commas or special characters because it's kind of like a part of the language which doesn't affect the palindromeness of a string. All right, so you have this classic palindromes like madam, a madam, right? So there is a comma after madam. And if you consider the comma, you don't have a lot of palindromes which make a lot of sense in the English language. So they typically ignore special characters. But let's say you don't want to worry about that. Let's say you're given a string without any special characters. So let's say the interviewer kind of simplifies it and says, oh, it's just alphanumeric characters, no special characters. Can a palindrome not exist? Well, that's a possibility. Yes, let's say the palindrome cannot exist. Let's say you have a string where a palindrome does not exist. However, I should say that there are different ways of handling this. If a string has no substrings with palindromes that exist, well, a single character string is a palindrome, right? 2 character strings can be palindromes if they repeat, but at the very least, just take 1 character and say this is the palindrome. This is the longest palindrome we can find. You have a whole lot of those. And then there's also a related question. What if you have 2 strings which are palindrome substrings, but they happen to be of the same length? Well, the interviewer can say, well, return any one of those. All right? These are great questions. All right, I hope some of you guys got this. This is one of those things where you have like the brute force approach, where you can just go like, I don't care about time complexity. All I want is to find the answer, and you just loop and loop and loop and loop. You can find the answer that way. But what we're looking at is what's the most efficient way to find the answer, and that's where the fun is, right? That's where the complexity of this problem lies. So this is not something that you can do with like O of n operation. You cannot just do one scan and try and solve it. I think you cannot do it in O of n square as well. We'll see, we'll work around this. But then this is a fairly intensive operation. But then the challenge is to see how fast you can possibly make it with the constraints that you have. All right, let's think about this. You guys know how to find if a given string is a palindrome or not, right? It's given a string. How do you find out if it's a palindrome or not? Well, that's actually, hopefully, fairly simple. So what you need to do is, let me erase this guy here. Let's say this is your string, A, B, C, D, E, F, E. What you would need to do is have a pointer at the start, have a pointer at the end, all right? Compare these 2 characters. If they match, move this pointer here, move this pointer here. Compare these 2 characters. If they match, move this here. So keep doing this. Have these pointers approach one another until they meet in the middle. They hopefully meet in the middle, in which case you say, okay, this whole thing is a palindrome because I've started from both ends. I've kind of validated both sides, and at each position they all match, right? This will work. But the problem is, for something like this, you need to know what the start point is and what the end point is. If you're saying, okay, given a string, and say, check if this is a palindrome, you know what the start point, you know what the end point is, and you can go this way. However, in this case, it's a little different. You have to see if any of the substring, any of the hundreds of possible substrings for this string happens to be a palindrome. What's the brute force way? The brute force way is to say, okay, I'm going to check for every start, I'm going to check for every end. I'm going to do this thing where I'm looping through and then checking each character one by one. And then at any point of time I meet in the middle, I'm going to keep track of how many of those characters I add to compare, which is basically I'm going to get the length of that palindrome, substring. I'm But I keep track of that somewhere and say, okay, I found a palindrome of size X starting at position N, right? And I'm going to keep going. So I'm going to do this for every possible start and every possible end. Okay, how do I do that? Basically a nested loop, right? So for I equals 0 to n, j equals 0 to n, where n is the size of the string. That can work. That can possibly work. But then you're basically looping, you're having a nested loop, which is O of n squared. And for each iteration of that nested loop, you're basically comparing the size, which is another loop which compares the individual characters. So this is not efficient. Is there a better way? Here's an alternative. So before getting into the palindrome substring problem, let's look back at checking if a given string is a palindrome, right? I'm going to give you an alternative way to check if a given string is a palindrome, and you will soon see how that applies to checking if there are substrings which are palindromes. All right, let me show you. So let's say instead of starting over here, right, instead of starting from the beginning and the end, let's say this is my string A, B, C, D, C, B, A. All right, so I want to check if this given string is a palindrome or not. Instead of starting from here and here, right, I'm not going to do that. What I'm going to do instead is start from the middle. All right, I'm going to start from the middle, and I'm going to expand this way, right? I'm going to expand on both sides. I'm going to check if this character is equal to this character. Okay, if yes, I'm going to move on, check this character is equal to this character. If yes, I'm going to move on. And then if I hit the beginning and the end, well, then I know that the string is a palindrome. It's basically the same thing. What I'm doing is essentially the same concept, but instead of having a start and an end and looping inwards, I'm going to start from the middle and loop outwards. All right, will this work? Technically this will work, but there is a small problem here. There is a small problem. What if there isn't a middle? Like the example that I showed you here, this one has a middle, which is D. This is the guy in the middle, right? What if I have another string? Let's say it's like this: A, B, C, C, B, A. Well, this is a palindrome. Well, now can you use this alternative approach, this starting from the middle and going outside? Can you apply this approach to finding if the string is a palindrome or not? You technically can, but what you need to do is detect that, okay, the middle happens to be 2 characters. Now we have to check if the 2-character middle is the same, and then if that's the same, go further. So you basically need to have this if condition to check, okay, is the number of characters in my string odd or even? If it's odd, you have a middle, you start from there and you expand. If it's even, you take the middle 2 characters, check if they're equal, and then expand, right? So this is, setting aside the problem that we're trying to solve now, setting that aside, this is another legitimate way of checking if a given string is a palindrome or not. Agree? That'll work. We might ask me, well, Kaushik, then what's the point of doing this? Because you have to have this additional complexity. If you're starting from start and end, it's simple, right? You don't have to worry about whether it's even or odd. You can handle that case when you meet in the middle. But if you're doing this, if you're trying to start from the middle and going outside, you have to handle this extra use case. Why do we need this? Well, here's why we need this. This is useful in our particular problem if we're trying to solve the maximum palindrome substring, right? Here's how it helps. This is my string. Now, if I were to find out what are all the possible combinations of substrings that I need to check for palindrome, we said if you're going with the start and end approach, you have a nested loop, right? And let me get this straight. First of all, I have to clarify, you have to check each individual substring for a palindrome, right? There's no other way around it. There's no magical way of saying, okay, now I'm going to do this little trick here so that I don't have to check everything. You kind of have to check everything. So the question is how we can optimize the everything part, all right? So let's look at this. If you were to look at the start and the end approach, right? So let's say your algorithm is check palindrome, and it takes in parameters, your string, start, and then end. Okay. Now, how do you identify all the substrings? Where you're going to have to do a I equals 0 to length, j equals 0 to length. Maybe you can optimize the starting point of j here a little bit, but then the fact remains that you're going to have to do all these loops, and for each loop you need to call check palindrome of the string I, j. All right, this is necessary. However, let's say I were to use this other approach, this alternative approach, which is check palindrome, where I'm starting from the middle. Take the string and then the midpoint. Now, if I were to use this method to check if a string is a palindrome or not, how many loops do I need? You guys see this? I just need one loop because I'm just passing in the midpoint here. So what I'm doing is, instead of doing a start and a end and then checking if each is a palindrome, I'm saying I'm going to do one pass of the string and see for each character if it happens to be the middle of a possible palindrome. All right? It's a slight shift in your thinking, but imagine how much it saves here. You're basically saving an entire loop by having that shift in thinking. You're saying, I'm going to do one pass of the string, each character, I'm going to expand till I find two mismatched characters. And like, okay, I found some palindrome. And you do that for each character. And there you go. You have a possible solution for the maximum palindrome substring. Here's what the code is going to look like. Okay, so let's say I have a class called solution. I don't usually put a class here but for this particular thing, I'm going to have a couple of member variables, and I'll tell you why in a bit. But let's say I have a class, and this is my string. This is my solution method. The longest palindrome method, which takes in a string, and it returns back the longest palindrome. All right. First thing I'm going to do is get the length of the string. And what is the minimum length of the string that I need to have in order to do all this business, right? Boundary check. That's the first thing you ask your interviewer. Do all the boundary checks and say, okay, what's the expected behavior? So in this case, the boundary check is a string an empty string? Well, in which case, you probably just want to return the string, right? Is a string of one character? In which case, what's the longest palindrome you can get out of that? It's that single character string, which is the entire string itself, right? So you basically need to check if your string is of length 0 or 1, then just return the string. You don't have to do any of the stuff. So that's going to be my if block here. I'm going to put an if block there and say if it's less than 2, just return. All right? Now to the actual stuff. What I'm going to do is I'm going to loop through the string character by character, and I'm going to check if each individual character is a possible center of a possible palindrome substring. And if it is, no matter how long the palindrome is, I'm going to keep track of that length. I'm going to keep track of that starting position. And then at the end, I'm going to say, okay, what's the biggest one? If I find a bigger one, I'm going to put it to that same variable. And in the end, whatever that variable holds is the longest palindrome substring, right? So what I'm going to do is, I'm going to start from 0. I'm going to go until string length -1 because of 0 index, start ++. I'm going to get the possibility of that particular value, start being the center of a palindrome. So imagine I create this method called expand range, right? So this is what this is going to do. Like check palindrome was the method that I wrote in the notes there, but we've called it expand range. You can call it whatever you want, obviously. So what I'm going to do here is pass in 2 arguments. I know there's 3 there, but bear with me. Pass in 2 arguments. One is a string. The other is the midpoint. Then it returns back the longest palindrome that it can get, right? However, this is not going to be enough. You remember with the midpoint check for a palindrome, like starting from the center and expanding up, you have another use case to think about, which is what if the length of the string is even? In which case you don't have one midpoint, you have 2 characters, a start and an end, all right? So that's the reason why what I'm going to do is I'm going to call the same expand range method with the start and start plus 1. All right. So what expand range does is it doesn't take one midpoint. It basically takes 2 all the time. But if the number of characters are odd, the range is going to be the same character, right? So because there is a midpoint, it's going to be midpoint comma midpoint. But then if the number of characters are even, it's going to be those 2 characters which form the midpoint, which is what I'm sending here by start and start plus 1. Right? They may not be the midpoint, but then again, we are just trying to see if, okay, are these 2 characters possibly a midpoint of a possible palindrome? So you have to check for each and every letter, each and every alphabet position in that string. All right. So how am I going to do this? Let's say I write this method, expand range, which takes in a string, takes in a begin and it takes in an end, right? It takes in 2 characters, and then it's going to expand till it finds the largest possible palindrome. Now, I'm going to create 2 member variables here because what I want expand range to return is 2 values. I want it to return the maximum length, and I also want it to return the position where it found the starting of the palindrome, right? I need the start because I need to do the substring. I need to somehow calculate the substring from the string and then return back, because that's what the longest palindrome method needs to return. It needs to actually return the substring itself, the biggest palindrome substring itself. So I'm going to keep track of 2 member variables, and then the expand range, all it's going to do is going to write to those member variables, and then when they're done, I basically do a substring of the result start and then the result start plus the result length. All right, is this clear so far? And of course, the reason I do this is because in the Java API for substring is basically the start and the end, right? You need to return the start index and the end index. So what I'm doing here is the result start and the result start plus the result end, the result length. Why am I not storing the result end? Why am I storing the result length? I need the result length anyway because we are looking at the maximum palindrome. So I need to keep track of the length anyway. So I'm keeping track of the length, and then I'm doing start plus length. All right. So as long as expand range does its job, right? Given a string and given a center point, which is 2 characters, it expands and then writes to result start and result length as long as it finds a palindrome which is bigger than this. As long as that's expand range's job, as long as that's doing its job, this main method, the important method, which is the longest palindrome method, is going to do its job, and it's going to return the longest palindrome substring. Right? So we have delegated that expanding range to the expand range method. Hopefully this is clear so far. Now let's look at the expand range method and see what it does. What does it have to do? It has to check if the character at the beginning is equal to the character at the end, and while it is true, keep going. So that's inside a while loop, right? So while character at beginning is equal to character at end, I'm going to do begin minus minus end plus plus. But then of course I also have the bounds check. So while begin is greater than 0, you don't want to keep doing this if begin is equal to 0 or less than 0. And at the same time, you don't want to increase end if end has reached string length, right? So while begin is greater than or equal to 0 and end is less than the length of the string and these 2 characters match, I'm going to keep expanding the range, right? So begin minus minus end plus plus. So you're checking if that thing that was sent is a middle of a palindrome, or at least as big a palindrome as you can find. Once you exit the while loop, it means that it's found a palindrome, or it just gave up right at the beginning, whatever it is, right? It's like the biggest palindrome you can find with that thing as a center. Now I'm going to check if the result length, the previous palindrome that I found, if that's smaller than what I found over here. So what have I found? It's n minus begin minus 1 because of 0 index, right? So I'm going to say n minus begin minus 1. That's the length of the palindrome I've found. Is it greater than what I found before? If it's greater, then I'm going to save it to the class member variables. I'm going to say result start as begin plus 1 because I've done a minus minus. Now I need to do a plus 1 to get back to the start of the actual palindrome. Result length is n minus begin minus 1 because of the 0 index of arrays in Java. So I'm going to get that length, and then I'm going to save it to the member variable of this class. All right, so this is going to keep happening I'm going to call expand range twice for each character, and then I'm going to check if that's the center of the palindrome, and then we'll find the biggest one that we can find, and then the longest palindrome method is returning that as a substring. All right, so this is our solution. Again, you can of course do the other approach, which is basically having start and end and looping through. Will work for the most part, but you are definitely going to get bonus points if you kind of explain your rationale and say, this is why I'm doing this. I'm going to start from the center and move outwards because I get to save on that, right? Start and end, you have two variables, so you need two loops. Center, you have just one variable, so you just need one loop to do that for each character. Questions?